Welcome to part 2 of the video on the Fundamental Theorem of Calculus. Let's review what we saw in part 1. In part 1 we started with a function, the graph of a function, and then we defined an area function. There is a function that gives us the area under the curve from a point A to a point x. A is a fixed point, and the variable, the independent variable is x. And a of x gives us this area because it is the definite integral from a to x of f of t dt. So we define this function and we prove that we can take the derivative of this function, and if we do that we get f of x. That is the height at the final point of this trapezoidal shape. So that's what we saw yesterday, and now we're going to prove the second part of the Fundamental Theorem of Calculus, and this is the part that is computationally useful. That is, it allows us to calculate definite integrals. So let's say that f of x is a primitive of f of x. That is, f is such that its derivative equals the function f of x. We already studied primitives when we just started to learn indefinite integrals. So this is a primitive, just a function whose derivative is the other function. And we also proved when we studied the indefinite integrals that the difference between two primitives of a function is a constant. And we also proved that a of x is a primitive of f of x because its derivative equals f of x. So we have that the difference between a of x and the other primitive f of x equals a constant for every x. So here we can solve for a of x, and we have that a of x must equal the primitive f of x plus the constant c. So that is, we can write the expression of a of x as the integral, and here we have an expression for the integral from a to x of f of t dt. But here we're not happy yet. Let's make x equals a in this integral and in this equation, because this equation is valid for any x. So in particular it is valid for x equals a. So if we do that, we have that a of a that equals the integral from a to a of f of t dt. That would equal f of a plus c. And what is this integral from a to a of f of t? What is this integral? What is an integral? And a definite integral is always an area. But here we're integrating the function. We're taking the area under the graph of the function from the point A to the point A. So we're only integrating on a point. And when we do that, what we get is this vertical line, this vertical red line here. And what is the area of a vertical line? That's 0. So a of a that equals this integral equals 0. So we have that a of a that equals f of a plus c equals 0. So here we can solve for the constant c. If we solve for it, we have that c equals minus f of a. So here we have an expression for the constant that equals the difference between a of x and f of x. So now let's make x equals b in the original equation, and we get that a of b equals the integral from a to b of f of t dt. That equals f of b plus c. That's just the original expression that we got. So now here we have c again, but here we have another expression for c. So let's replace that. If we replace c by minus f of a, we get this equation. And here we have an expression for the integral. We have that the integral from a to b of f of t dt equals f of b minus f of a. And this is a really important formula because this is a general formula for any integral of a function from point A to point B. You can use this formula. And what is f here? What is capital F here? It is, we just define it as a primitive. So this formula is valid for any primitive of the function f. And we are already experts in finding primitives of functions. That's just what we did when we studied indefinite integrals. We learned a lot of techniques for finding primitives of function. So what this formula says is that if you want to calculate this definite integral, you only need to find the indefinite integral of the function and evaluate it at b and take the difference by the indefinite integral evaluated at a. And we're going to see a lot of examples of that in the following videos. So that's all for now. Thank you for watching and see you next time.